I'm going to give a brief overview of how IceCube has been has experience in the cloud and how we're sort of assessing it over time. So just briefly, IceCube is a neutrino observatory located at the South Pole. So we're the detector itself is basically embedded in the Antarctic ice shelf. We have 5,160 of what we call digital optical modules, which are basically very sensitive light sensors. And they're about a mile deep in the Antarctic ice. And we basically try to look for astrophysical neutrino, high energy astrophysical neutrinos, so anything very high energetic that travels or can travel through the ice. Or on the science side, we're sort of a novel instrument on multiple stages. We have a broad science abilities, so we have astrophysics, particle physics, and earth sciences are sort of our big three. But as you can see, there's also a lot of different sort of subsections to those that we cover. That means that lots of our data needs to be processed in different ways to accommodate these various different science goals. And also, as sort of a standard particle physics experiment, there's a lot of simulation needs to be done. So we sort of cross-checking our data with what we believe is the best operation of the detector or model of the detector. So IceCube computing, so as I said, it's a particle physics experiment, so it's also has sort of leads a lot to the particle physics computing. I mean, we can talk about embarrassingly parallel, ingeniously parallel definition, but basically we're sort of in this sort of very high throughput computing realm, and we do globally distributed computing. So here on the map, you can see from Madison out where we're headquartered, we basically cover the entire Earth in terms of sites where we do our computing. We at Wisconsin, we basically provide the full stack IT services for about 400 people, depending on any given time, which is across 53 institutions in 13 countries. So this is the entire collaboration. Basically, people have access to the data. This ranges from the sort of the basic IT services, so email, document management, etc., to large-scale distributed computing. So we have a very broad gamut in terms of things that we do. But the cloud has already touched us in some ways. So, for example, we're transitioning our business services from on-prem to cloud services. We're already using cloud services. So, in case, for example, Zoom is sort of a canonical one here. And a lot of these things, I mean, we can see one thing we've heard about today is sort of this lack of resources necessarily, but ultimately, IceCube also has a lack of resources in terms of, total computing. And the cloud compensates for that, at the end of the day, it comes at large costs that we and our current mode of operation and funding cannot pay for. We did do with our help with our friends at SDSC and UC San Diego, we did a large cloudburst demo, which was, we wanted to create an exaflop scale computing tool in the cloud. And we didn't achieve that goal, but ultimately with the funding from NSF, we were able to sort of achieve we were able to do 3 different experiments. The first one was kind of creating the largest GPU pool in the cloud, which was roughly at the scale of DOE Summit. So the number one on the top 100 at the time. And we distributed our workloads across basically all geographic regions in the cloud. In the second experiment, we basically took a more realistic test where, in the first one, we coordinated with the cloud vendors, but in the second, we just basically started up VMs and let them operate. And, we had them over 8 hours and then basically got an exaflop hour of compute. So it's an integrated exaflop over those 8 hours. And then on the third experiment, we went with sort of the network peering between clouds and UW. And basically, we were able to saturate 100 gig. Basically, we were looking at having 100 gig link between the UW Madison and the different clouds And basically, we had to use multiple clients and and we had to use two peering. One of the big things that came out of this is kind of the elephant in the room for everyone is the cloud, but then also nobody really knows what it is for them in many ways. If I were to talk to, or if I were to survey everybody in the room, I think I would get 100 different opinions of what the cloud is and what the cloud does. And that theme continues throughout. I mean, we have tried this in some ways today as well, where there's some level of institutional hesitance and also social engineering. So, for example, us at UW-Madison, it took us 18 months to negotiate a contract with GCP. Before that, we were basically on our own. We already had a contract with AWS, but I mean, that it seemed to have taken. But before we already had a contract with AWS for 4 years. When you consider the standard NSF grant is 3 years, I mean, in the major facility world, it's a little different since we usually have 5-year grant cycles. But still, 18 months out of 5 years is a long time. There's a question about how should a small school or program do this if you're not a major facility or you have the backing of your university necessarily. Like, how do you actually interact with the cloud vendors? And NSF is approaching that through things like Cloud Bank, but it's still in development. And then, of course, the question is, what about other vendors? I want to go to Oracle. I want to go to DigitalOcean, Linode, and all these other ones that are cropping up across in this space. And it's very much sort of they have a nice business. They have a better business. I say a more accommodating business model, but if I need 18 months for every single one of them, then I'm going to be, spending the next 5 years just arguing about contracts. And then the big question is the sort of having the budget. We have a hard budget, and what do we do when we spend over that budget? It's not like we can go back to NSF and be like, whoopsie, I need another $2 million. I don't think that you'll get any more funding if that happens more than once. And then there is also this question of inconsistent overhead policy, so indirect costs, whatever you want to call it. So in some places like UCSD, there is no overhead. At UW-Madison, there is overhead, so you have a 50% swing in the costs compared to regular computing. But then also between universities, so you're basically, if your MF is hosted at in an unfortunate place, you're spending 50% more for no particular reason. Similarly, it's now unclear, how this will continue over time. Again, Internet 2 and sort of these strong interconnects between the cloud and Internet 2 have made it viable, have made the cloud viable for large scale science, but there's still, an open question in terms of if it's, reasonable to buy compared to, getting a quote unquote free service from Internet 2 for most of your network traffic. So on the second part, there's also this question about the cloud in terms of SaaS or software as a service or other services that you give the cloud, like Google Workspace. We heard about this earlier today. GitLab. For an MF like us, and I'm assuming that any of the other MFs that have multi-institutional members, you're caught between a rock and a hard place. The campus-based SaaS is negotiated for the campus and not for your multi-institutional collaborative science case. So you really are, you can't get some of the say advantages that they get. For example, free Google Workspace or the like. Similarly, then you get into the whole IAM mess in terms of then you have to you as a faculty member or as a staff member have access, but then your collaborators don't. and you have to add them by hand or have to have some kind of automated system to add them to the SaaS. So using campus provided SaaS is usually a huge headache. The big thing here also is that science is becoming more and more collaborative. We're not like the one faculty member in a lab somewhere doing science anymore. We have multi-institutional collaborations. And then providing these business services for non-W folks can get expensive. So, for example, if I have a 400 people collaboration and I want to have some kind of service for them at $10 a head a month, that is $4,000 a month. That is an over that might not seem a lot, but if you're stretched for cash or you're not necessarily the best funded place, $4,000 a month is not necessarily a small amount. Also, then the question is, can you host this by yourself? And then the question, of course, comes: is hosting it yourself cheaper? The big other thing, of course, is, as I just mentioned, the billing part is. At the end of the day, there's an unknown cost factor that that can happen. So, for example, you can run your bill up, you forget something, you don't have rails in place, or but also the cloud doesn't give you those rails necessarily. Is that your bill can run up into the millions per day if you're not careful. And of course, that runs into an issue with funding agencies and campus administrations. And generally, campus don't like just handing out credit cards and things like that. And of course, then you have the push towards the free existing resources. We referred to this earlier today with, Exceed, the DOE, HPC resources or campus resources that really provide a service which may not be sufficient at first look, but then if you think about the cost of the cloud and also the cost of the that the universities have put into these services, then they make more financial sense from that point of view. And that's it from my side.
Great. Thank you, Benedikt.